Hello, everybody. We are in the November 17, 2025, in this first webinar promoted by SAGE project, subseasonal applications in agriculture and environment, which is a project connected to World Weather Research Program. And this first webinar is organized in partnership with COPE project, Capacities of Organizations to Prepare for Extreme Events, which is a project coordinated by CEMADEM, the Brazilian Early Warning Center, and funded by São Paulo Research Foundation. For this first webinar, we are honored to receive Juan Bazo, who is an expert from the Red Cross Climate Center. Juan, welcome to our first webinar of SAGE project. And I give the floor to you for so you can introduce yourself and start your presentation that will discuss about the use of subseasonal forecast information for disaster preparedness.
Thank you, Victor. Good afternoon, everyone, and thanks for joining today. My name is Juan Bazo. I am Senior Climate and Data Advisor at the Red Cross Climate Center. The Climate Center is a reference center for the International Red Cross Federation. And today, I will present uses of seasonal forecast information in disaster preparedness. In my presentation, I will explain what S2S forecasts are, why they matter, and what is designed to support them, and how the humanitarians and the governmental system can operationalize them. This presentation combines scientific foundations, sectoral applications, and real case study to illustrate the practical value for S2S. Traditional disaster risk management, next please, for the introduction, Victor, sorry. Traditional disaster risk management are based in short and medium range weather forecasts up to 10 days, and seasonal outlooks, the 3 or 6 months. The subseasonal windows, 2 weeks and 2 months, was long considered unreliable several years ago. However, advance in the dynamical model, ensemble prediction system, and understanding of the tropical oscillation are helping fills this predictability desert. Today, S2S forecasts can provide probabilistic guidances for hazards such as heat waves, extent rainfall, potential flooding, and drought onset. This creates a new preparedness window, allowing institutions to activate readiness and anticipatory measures well before the event strikes to the community. Next, please. The scientific basis for S2S forecasting includes a large-scale mechanism. Some source of subseasonal to seasonal predictability are founded in several scientific studies, like papers that I will present in this slide. The Madden-Julian oscillation, MGO, to know many meteorologists and climatologists know this pattern as a dominant mode of intraseasonal variability organizing the convective activity around the world, around the Ecuador especially. The NGO has a considerable impact not only in the tropics, but also in the middle and high latitudes. And this is considered as a major source of global predictability on the subseasonal time scale. Some reference here. Another one is the soil moisture. The memory in the soil moisture can last several weeks and influence the atmosphere through the change in evaporation and surface energy budget, affecting subseasonal forecasts of the air temperature and precipitation over certain regions during certain seasons. Some reference for this study show you in the slides. Snow cover, the radioactive and thermal properties of the widespread snow cover anomaly have a potential to modulate local and remote climate over monthly and seasonal time scales. Stratosphere or troposphere interactions. This is a signal of change in the polar vortex, for instance, in the northern annular mode or Arctic solar oscillation, the NOW or AO, are often seen to propagate the downward from the stratosphere with the anomalies in the troposphere. Flow lasting up to about 2 months, lead times, for instance. Another condition is the ocean sea surface temperatures. Anomaly in the sea surface temperature lead to change in sea heat floods convection with affect atmospheric circulation forecast of the tropical interseasonal variability are found to be improved when the couple model is used. For instance, this is a typical example that always I give in terms to the subseasonal forecast using anomalies or sea surface temperature is when El Niño, coastal El Niño or El Niño costero, no Peru and Ecuador appear very quickly. So some signal for subseasonal forecast give us this window opportunity to prepare, for instance, the population or prepare disaster management to the preparedness in themselves. And next, what is the key hazards that S2S forecast and the skills? In some countries, they are using for different hazards. Typhoons are using in several countries in terms to the tropical cyclone formation. The lead time was around the two weeks, and the skill approximately is medium, low skill when we use 3 or 4 weeks in advance. Floods and wet spells normally uses in different countries related to the NGO, for instance, for rainfall, for using 2 weeks in advance, and the skill is really medium. This study was done by SCAP. This is a UN agency in the Asia. Another hazard is drought or dry spell using different indicators like dry spell or consecutive days events, weekly rainfall updates or drier than average. This is a different product in terms to the prediction. Probability of below normal will use not just in a seasonal scale, also in subseasonal scale. Heat wave, this is a great phenomenon or hazard that we can use S2S. For instance, in several countries, we can use, and the case study I will show you what we are working with some universities and others. Cold wave and another hazard as well. So we normally use 2 or 3 weeks in advance with medium and high skills, Another, when we use 3 or 4 weeks, we basically give some low skill in terms to the preparedness. Some applications in terms to the across different sector is very relevant for us in terms to the use this kind of information for multiple sectors. In agriculture, we are use this kind of forecast to crop planning, irrigation, pesticides, using pesticides or disease management in the crops, for instance. For energy, we anticipate the demand of jobs for hydropower optimization, for instance, or for energy or winds for some clean energies companies. Water resource, we can use this different, can you put the slide for applications, Victor? Energy, water resource, in terms to the different sectors, help. We can use a health public in terms to the early warning for vector disease, for instance, or for heat wave or cold waves. We can prepare the different hospitals or prepare in terms to the sanitation, use a different kinds of products. For water resource, we can using reservoirs level, flood risk management, so many actions that we can use this entire the decision maker using S2S forecast. Our focus in this presentation is for disaster risk reduction, so we can move another slide. Next, please. And what are the benefits for disaster preparedness? For disaster preparedness, we have many interventions using S2S time scales. We examples to hazard mitigation, we realize water farms from the dams and prevent collapses, protect infrastructure, activate institutional process into the national disaster risk management system. We allocate some resource in terms to the prepare the community or the branches, for instance, in the Red Cross. It's using child responsibility social protection systems in terms to protect the community in the ground, activate existing contingency plans and coordination structures in the national system or the regional system or the state system, alert volunteers, ensure the ability of sufficient volunteers in affect potential areas that we will affected, provide media distribution with instruction, early warnings, announcing, distribution, many item relief in some key areas that we are intervening. So evacuation routes, prepare the evacuation route, addresses a specific vulnerability. So we are manage many things in terms to the using these benefits to S2S for disaster preparedness. Next one, please. The report for CALF S2S window is a critical opportunity for preparedness. Before the detailed local warnings are possible, but after early signal appears, this is a stage where resources can be mobilized effectively. Normally, as I explained in the slide before, the National Risk Management System using this kind of information, not in terms of the time scale, a short range using 1 or 3 days forecast in advance, or medium range 3 or 10 days. No, this short to medium range weather influence action as issue warming, distribute humanitarian aid or evacuation. The other interesting information that disaster management uses normally is the long-range forecast, no, seasonal forecast, and in terms to the action, starting monitoring forecast, update contingency plans, or inform strategic planning for decision. But for us, the focus is to extend this range between this window opportunity between 10 and 30 days. This is the cover S2S window opportunity. What kind of actions we can use when we have this window opportunity is to continue monitoring forecasts, update community warnings, initiate preparedness activity, revise water allocation, activate water conservation practice, supplement financial risk strategy, inform loss scenarios, update peak energy demand in scenarios, prepositioning disaster response material, implement irrigation, pesticides, or fertilizants for different sectors that we can see in our presentation, as a slide presentation before. In next one, we are focused now on some key examples using S2S, especially using S2S in action. This is example taken by presentation for RRI Andy Robertson, Freddie Vitar from ECWS to present in the AGU fall meeting in December 2019, where they are showing this example using ECWS Genesis tropical cyclone forecast. They show this example using the 1 week and 4 weeks for tropical cyclone or typhoon Kamuri in Philippines. This information that they show in this meeting basically showing that the signal, the formation, the genesis formation for the tropical cyclone in Philippines using a different time scale as S2S. One is issue around the 11 November, and another one is 2 December, when we have just 1 week for a tropical cyclone strike Philippines. So the conclusion is we can get information in terms to the preparedness 3 weeks in advance. So this is interesting in terms to the disaster management, take early actions or take actions before the typhoon strike in the Philippines. Next one, another case study to S2S. I show you 3 case studies. One is in Philippines and Myanmar, the rainfall, extreme or heavy rainfall in Malaysia and Indonesia, and heavy rainfall in Vietnam, all in 2016. We show different observations in the first column. We can see the Philippines, and the second column Malaysia and Vietnam. In this column, we can show observation prediction 2 weeks in advance and S2S prediction in 3 weeks. So the idea is not predict as a meteorological short-term predictions. So the idea is to look the signal as the S2S give us in terms to the preparedness. In these three examples, next one, please, Victor. The SCAP in this study, they bring us, they mention different approach that the impact for this every case impact in the different in different countries. What is the event? Basically, in Philippines and Myanmar, the S2S prediction were available to predict more precisely than expected in terms to the dry spell. So they are predicted some drought conditions in this part, and the impact reported in this especially week in the 9th and 15th May, but resulted the persistence of the El Niño condition, extreme temperature, unusual rainfall patterns, and crop failures, and fires and acute water shortage affected. In the north of the Philippines, 12,000 families lost over, and 70% of the crops was affected. In Myanmar, also water isolated village from waterways, damaged some tourists, agriculture, and livelihoods. In Malaysia as well, evacuate many people in terms to the rainfall, heavy rainfall, overflowing rivers, some deaths in terms to the landslide, thousands of houses damaged, thousands of people lost life or displacement in this event. And flash flood affected around the 8,000 people, and 100 people evacuate in this event. In Vietnam, also 15 people were killed. Irrigation and hydropower reservoirs reached the maximum capacity and need the control water realized. Nearly to 12,000 houses affected, many roads, bridges, and other infrastructure were flooded, damaged, and crop and livestock as well. So some real cases that using S2S can be mitigate this kind of impact. Next one, please. I will present this because recently we are developed early action protocol from the Chilean Red Cross using this research, especially this research was led by University of the Concepción in Chile by Dr. Jacques Cooper, where they can find in this paper the important interseasonal teleconnections to lead the heat waves in the central and south part of Chile. In this case, we can use this mechanism that the Dr. Cooper found in this paper, because they are operational now. The University of the Concepción create an index operationally in terms to give this window opportunity in terms to using MGO indicator. When the genesis of this NGO to reach Chile, we have the window opportunity around the 15 days to prepare when the heat wave is taken. In this paper, they found several cases to using this time scale forecast. So now we are develop this EIP in terms to predict the heat waves 15 days in advance, especially in the central and south part of Chile. Next one is the recently case that we are supporting, especially in the Central Caribbean, for Melissa hurricane, 3 weeks ago, we use this information or this product from NOAA for the Climate Prediction Center from NOAA. This tool or this product they call Global Tropical Hazard Outlook. They are updated every week and using 2 weeks and 3 weeks in advance for global topics. In this case, they are presenting, or the issue was elaborated in the 10th of 7th November, and when the tropical cyclone recently genesis in the Caribbean Sea. So we send this information for many Red Crosses in the Caribbean, also prepare many countries and islands in the Caribbean in terms of the potential impact in terms of this tropical cyclone that then finalized as the worst hurricane in the Caribbean Sea, hitting Jamaica, Cuba, and Bahamas, Haiti, and Dominican Republic. In this case, we can use this signal 3 weeks before Melissa formed in the Caribbean, some action that the Red Cross using imminent threat operation. This is a mechanism that the Red Cross has in terms when we have an imminent hazard to hit some islands. We preposition supplies, we support the national coordination, and we activate some anticipatory action framework in terms to mitigate the impact, especially in Jamaica. Next, please, is one framework that the Red Cross using, call it Ready, Set, Go framework. The idea that this framework is to translate the forecast in different lead times into the actions. When we talking about ready, we use a long-term preparedness, capacity building, seasonal planning. This we can use this information using seasonal forecasts. Then we move to the set. We use in this case we use a subseasonal forecast in terms to have this window of opportunity between 2 weeks and 2 months. The action that we are putting our focus was increasing the monitoring and early readiness measures. And when we use a go in this approach, we use a weather forecast from 1 day or 0 days and 10 days. And basically this is this kind of forecast is to activate anticipatory action when the risk becomes sufficiently high or skill S2S, and we activate basically anticipatory actions. One example, next please, is this EAP, Early Action Protocol, using for the Ecuadorian Red Cross. When we use this approach, Ready, Set, Go, to effectively integrate S2S forecast for decision making. No, the idea is to have a probability threshold linked with a specific action, alignment between scientific uncertainty and operational decision structure. Especially in Ecuador, we use information from the Ecuadorian Net Service, INAMI. When we receive this information, the Ecuadorian Red Cross activate some actions that they are covered in the early action protocol that they approved by International Red Cross Federation. This example was in 24 when El Niño hits the coastal of the Ecuador. Next one is basically the collaboration based in science. We work really close with the National Hydromet Service in terms to the tailored forecast. We include the co-developed user product, build the local interpretation capacity to collaborate between meteorological service, disaster authorities, sector agencies, and the capacity build to ensure the forecasts are understood and they acted upon currently. So those examples, the operational subseasonal forecast was realized by CPT INPE, and other example is in Peru, and the Peruvian Meteorological Service as well. They are both are operationally in terms to the using this kind of information of the S2S for 4 weeks in advance. Next one, and the last one is, I think, what is we promote, or we is promoting STS products in terms to the using for disaster risk reduction. Future work is required on both product development and application size to fully harness to the social benefit of S2S prediction. Although additional research is needed in terms to the give rigorously evaluate and usability and the real world performance of S2S products. Important efforts are already underway to build the scientific and institutional capacity to give this production of the this kind of forecast, apply this information. Through several ongoing S2S prediction projects, a number of the institutions are working to improve the forecast skill, especially in this subseasonal time scale, and promote the operational update of the forecast by the end user. This is the idea that we can promote S2S that is useful for the institution or organization. Lessons from the more than 2 decades on efforts to integrate seasonal climate prediction into the decision-making process show that users often face a significantly constraints to apply climate information, include the upset to the mechanism to enable them clearly articulate or communicate the information needs for disaster management or organization to take decision with this kind forecast. As a result, meteorological agencies frequently forecast what they are technically able to produce, but rather than generating information tailored to users' operational requirements, demonstrating that value of the S2S prediction is essential for increase their adoption and building demand. At time when disaster impacts are rising globally, innovation is urgent need to reserve current trends. We look to climate science. It's not only for advance in prediction capabilities, but also innovate application that generate tangible social benefits for the communities especially. We encourage to invest in learning about the S2S products and prepare national systems to use S2S information alongside the weather and seasonal products. Doing so will strengthen multi-scale risk assessment, enhance preparedness, and ultimate support for more effective and early warning and early action systems. Next one, some conclusions. The subseasonal to seasonal time scale fills a critical gap between short range forecasts and long range forecast outlooks. Operational S2S forecasting is nearly staged. There are significant potential for application ready capabilities across the sector: public health, disaster preparedness, water management, energy, and agriculture. Key unlocking value from S2F forecast is not just scientific skill, but also translation of the forecast into decision support tools, effective communication, and integration into the user workflows. Some challenges remain. This include improving forecast skill beyond the 2 or 4 weeks lead time, tolerating forecast for specific user context, building institutional capacity, and linking between science and applications. Next one for the recommendation, basically invest in research to improve the predictivity skills of the system, especially understanding the source of the predictability, and extend the skill future into the subseasonal horizon. Develop user-oriented forecast product. This is the key in terms to the using S2S. Convert the raw forecast into the actionable information, probability, triggers, decision thresholds, suit the sector and disaster risk reduction. Strengthen the interface between the scientist, decision maker, incorporate social science, co-production approach, and effective communication strategy to ensure the forecasts are usable and trusted. Embed S2S forecasting into the operational frameworks and planning cycles across the relevant sector. That is not a standalone product, but as part of the integrated risk management system. And finally, conduct evaluation at add value assessment for S2S application, measure how the forecast information leads to improve decisions, costing saving, risk reduction, and consider the user perspective. So, and this is my last presentation, and thank you so much. And if you are have some question, so please feel free to ask. Thank you.
Thank you very much, Juan. We have some questions on YouTube, but also here in the room, which is composed of a lot of master and PhD students in disasters, but also in Earth System Science. So I will start with one question from YouTube, from Christopher Cunningham. He is a climatologist at Semadem, and Christopher had the opportunity of interaction with the S2S project during the pandemic. So the question of Christopher is, how can we increase decision makers' confidence in subseasonal forecasts, given that their accuracy depends on windows of opportunity and is typically not very good beyond the second week?
Yeah, I think that this is a typical uncertainty after the second week and S2S. So as I can show, and in terms to the put S2S in more actionable user for disaster management, for instance, the idea is to create, for example, in anticipatory action, we can use different approach. When we have the skills of the forecast, we see the low skill the forecast, we can use low cost actions. But the idea is to support the community. The idea is to engage the community in terms to the preparedness. If we can see high skill, we put more effort in terms to the actions to move more volunteers, to move more item relief. Yeah, this is depends. So we need to see, to review the skills, to review how the performance of the hazard that we are supporting in the community. But this is the key, is the co-production, the co-design, the action in terms to the key information that the forecast gives us.
Our next question is connected to Christopher's question, but also your reply to Christopher. Paula, which is a PhD student in Earth System Science, she asked what strategies help bridge the gap between the S2S forecast producers and decision makers who need to act on them. Can you give some examples, but based on your experience around the world?
Yeah, absolutely. Yeah, this is a long-term process that we have experienced. As you know, I am a former climatology in the Peruvian Med Service. In 2015, I joined to the Climate Center to starting a pilot project using climate information before the event, the extreme event strike the community. So we try to organize this in terms to improve the relationship between science and practice. We are working very close with the Disaster Management Office and Med Service in terms to the dialogue, to building better products, to building better actions. This is the most procedure that we are recommend in terms to give this strategic in terms to the bridge or improve the gap between the S2S forecast producer and decision makers.
Juan, we have one question from Victor.
Hi, Professor. You said about S2S helps to understand the ocean and climate measure, but the S2S prediction can understand better coastal systems.
Yeah, it's not. Yeah, I use the example from the coastal El Niño in Peru. In 2017, for instance, we have a strong coastal El Niño in Peru. But when we extend, or normally when the Peruvian government have a group, the scientists to monitoring El Niño, every monthly they have a lot of information from the model, from the observation, from the environment especially, and they detected well El Niño in terms to the seasonal forecast information. But when some model, especially when after El Niño, coastal El Niño hits, especially the coastal part of Peru, we try to look the S2S signal. So in some models, especially UK Met Office model and ECWF model, we can find that these two models have good information in terms to the lead time for El Niño, coastal El Niño. I know it's difficult, especially in the Peruvian coast, because the system in Peru is not persistent because we have extreme upwelling that not mix the water seas cold weather, hot weather coming from the Ecuador. But in terms to the persistence of the 2 or 3 weeks, the signal for this kind of model give good information in terms to the take decision in this case of Fidel Costa El Niño 17 year. But yeah, still we can following the studies, case studies in terms of how the sea surface temperature we can use to initialize some models, especially for this time scale S2S. Thanks.
Thank you, Juan. We have other question from the YouTube that's connected with modeling and other ways of doing science in this AI era, right? So Christopher asked, have you used AI or do you plan to use it in the projects mentioned? What would your strategy be?
Yeah, thanks for this question, Christopher. Actually, we are looking for some tools and some AI models. Especially, we have a good exercise in looking Google AI models. For Melissa hurricane. The performance, they are still in discussion, but I think the AI will have the opportunity to give in terms to the probability and in terms to the lead time, I think in the future give more confident information. But yeah, still now we need to cover, we need to following, we need to research in terms to the case by case examples when we use this kind of information. Also, ECWF are still the European Center from Forecast. Now they are sharing the EI forecast operationally. So I'm not sure if this is into the S2S time scale, but for short-term forecast, definitely they are sharing this kind of information.
Thank you, Juan. We have a question from Annalise.
Hello.
Hey,
So you mentioned this at the end, but could you elaborate on the challenges involving translating in the probabilistic S2S outputs into concrete preparedness actions?
Yes. Basically, in terms to the probabilistic, many models give us in terms to the ensemble forecast. So we will calculate in terms to the probabilistic and outputs in terms to the define what is the thresholds that we can take actions. So in example, I can put for Ecuador and in others, we can use this typical probabilistic in terms to the terciles and how much or how low the probabilistic output from the models in terms to the decision makers for precipitation, for instance.
Thank you, Juan. We have a question from YouTube from Paula. How can S2S information be understandable and actionable for the general public who mostly sees only short-term forecasts?
Yeah, still more work or focus in the communication S2S output or S2S forecast using this time scale compared to the short-term forecast. Because still people thinking that S2S are unreliable. But yeah, this is the idea that how we can promote into the several groups or projects to give more reliable information for using S2S, show this case or success case study or no success case study as well in terms to the give or give us or give them people or decision makers in based in the lesson learned. The idea to using lesson learned approach is to all the system, include the communicators, include the scientists, to take yeah, this is real use where when and where we can improve or learn more, include the community, no? Especially the community, how can or how we can say, no, in 3 weeks in advance, we have the high probability that we can flood. So you need to evacuate. This is not a commitment or reliable for the community, for instance. 3 weeks ago is too much. So yeah, but we can use is already some actions on terms to the awareness to the community, but then we can use another forecast in terms of the short-term preparation.
Thank you, Juan. Carol.
Hi, Juan. Can you hear me?
Yes.
Thank you. Thank you for your presentation. I'd like to ask if you have some examples of shock responsive social protection measures that were implemented or activated after the S2S forecasts.
Yes, definitely we have in some project for anticipatory action using different time scale. We use more for social protection in itself. In Africa, WFP, the World Food Program, for instance, using a lot social protection in terms to the preparedness cash transfers, basically, in terms to the preparedness community. So they are using these time scales into their system, but also share with the government systems using social protection. So yeah, I not put in my presentation, I mentioned, yes, but if you need some example, I will send you if you need.
Thank you very much, Juan. Just to finish this first webinar series, you mentioned the importance of building institutional capacity, right?
Yeah.
And what types of capacities?
Yeah, good question. I mentioned in general, so the capacity, well, is different ways. One way is in the med service, definitely to include this kind of forecast in operational mode in terms to evaluate this kind of forecast, the skills, the lead time, if this kind of forecast is useful for the people or the communities or decision makers. So this is the why the med service are need to involve into provide this kind of forecast. For another side, for decision makers, yeah, also, this is the key in terms to the improve the windows opportunity to preparedness. As I mentioned, we still, as a Red Cross, we are still using this information because they, in some cases, they give a signal. In some cases, they give a strong signal and they get a signal, or sometimes missing, but when they give a strong signal, we have the opportunity to prepare not just to our volunteers, our staff in the Red Cross in the country, but also to prepare the community's awareness. So this is, we mentioned in our projects, we are not regret. So we are involved in the community and try the preparedness from them in take action when the hazard strike the communities or in some areas, the countries that we are working.
Thank you very much, Juan. I also need to thank you, these early career researchers that prepare a lot of interesting questions, and our participants on YouTube, and hope that you can follow us, our SAGE activities, and we are preparing the second webinar, and hope that you can enjoy to engage in this network. So thank you very much, Juan, for your time.
Thank you, Victor, and thank you all for the great questions and be here.
Bye bye.
Thank you. Bye bye.